Simplify all the way. Square root 15 over square root 12. To solve this problem, to simplify, we want to figure out what are those simplifying rules we have to keep in mind. Here are Brooke and Sophia's most recent reminders. Keeping in mind the radicand cannot be a fraction. The radicand is a number inside the radical symbol. Also, the radicand cannot have a perfect square factor other than 1. And lastly, when simplifying radicals, there cannot be a radical in the denominator. So if there's a fraction involved, that bottom number can't have a radical. Brooke and Sophia were also nice enough to list for you the first 20 perfect squares, which will help us remembering rule number 2. And then lastly, they have given us the 2 reminders that if we take 2 numbers that are being square rooted that are getting times together, that's the same thing as taking the 2 numbers multiplied together inside 1 square root. So basically just multiply those numbers and keep them under 1 radical. And lastly, the square root of any number getting squared is just that number. This works for any variable and any number. So the square root of c squared is just c. Thank you, Brooke and Sophia. So with that being said, we know with this square root 15 over square root 12, I need to get rid of the square root in the denominator here. In order to do that, what I'm going to do is I'm going to multiply my entire fraction here by the number 1. I know if I multiply by 1, I don't change the value of my fraction that I have here. So I'm going to do that. But instead of just multiplying by the number 1, I'm going to make my 1 look different. And when I work with fractions, I know I can get the value of 1 by having the same number on the top that I have on the bottom. So when you have a radical in the bottom, what we do is we want to multiply by whatever is this denominator. So I have square root 12 over square root 12. The nice thing about this is now on the bottom, when I do square root 12 times square root 12, I have a situation like this over here. I can just do the square root of 12 times 12, and that's going to give me what essentially turns out to be canceling out the square root on the bottom. Square root 12 times square root 12. On the top, I'm just going to multiply these two together. I get square root 15 times 12. So I can simplify the bottom by turning this into square root of 144. And on the top, when I do 15 times 12, that's going to give me the square root of 180. Square root of 144, I know is just going to simplify to the number 12. That's the whole beauty of this. That's why we're doing this in the first place. When I do this over here, that just cancels out the square root. I end up with just the number 12 in the denominator. That's my whole goal. So we've now simplified to the point where we do not have a radical in the denominator, but we need to also make sure that we're satisfying rule number 2 of not having any perfect square factors. So looking up at my numerator, the number 180, I need to see, do I have any perfect square factors in the number 180? So just like I was doing before, I want to look at my list here and find the first number that's less than 180, which is this 169. And I want to go through and ask myself, can I divide 180 by 169? Can I divide it by 144, 121? And keep going until I can evenly divide my 180 by one of these numbers. The first number that I can evenly divide that by is going to be the number 16. And so I'm going to break, is the number 36. I'm going to break this apart then into square root 36 times 5. And I do this, so now I can simplify this even further. Square root 36 times 5 becomes square root 36 times square root 5. And square root 36 simplifies to just simply the number 6. My 5 is not a perfect square. That stays inside my radical. And I still have my denominator of 12 on the bottom. The last thing that we need to do, though, is because we are working with a fraction, fractions have to be written in simplest form. So I want to look at my numbers outside the radical only, my 6 and my 12, and ask, is there anything that both 6 and 12 is divisible by? And in this case, yes, they're both divisible by 6. So my final, most simplified answer is square root 5 over 2.